It is 1 o'clock, so we're going to go ahead and get started. We've got a few more people logging in. So while they're logging in, we'll go over a couple of housekeeping items real quick here. If you want to ask a question during the presentation, please use the Q&A window. It's either at the top center or bottom center of your screen. If you enter a question in the chat, we may not get to it, but the Q&A window tracks which questions have been asked and answered. So we'll be sure to either answer your question during the presentation, or if we aren't able to during the presentation, we can follow up with an email afterwards. So please do make use of that Q&A window as we go through our presentation. We'll also have a couple of polls as we go through the presentation, so I'll be looking for those just to see if we've covered the topics well enough for your understanding. So my name is Sean Maurer. I'm an engineer at the Smart Energy Design Assistance Center based at the University of Illinois in Urbana-Champaign. Joining me today is our guest speaker, Todd Abercrombie with Midwest Energy. So let's get into what we're going to cover today. First things, main topic today is talking about verification and testing for compliance. So we're going to be learning which sections of the Energy Code require testing and verification, understanding what those requirements are, how to do those tests, which is where Todd's really going to help us out. And we're also going to touch on, for existing buildings, the benefits of doing testing and verification for improved performance. CDAC is a preferred education provider with the International Code Council, and we do offer continuing education credits for AIA. So after the conclusion of this webinar, you will receive an email with a certificate of completion for attending this webinar. In that will be a form link where you can enter your AIA member number, and that will allow us to submit credits for you to AIA. The Smart Energy Design Assistance Center is an applied research program at the University of Illinois, housed at the Urbana-Champaign campus. And our goal is to reduce the energy footprint of Illinois and beyond. These energy code training programs are one method to do so. We would like to thank our sponsor, the Illinois Environmental Protection Agency's State Energy Office, for sponsoring this training program and helping us bring this training to you. We also offer technical support and online resources for our Energy Codes program. You can reach us at energycode@illinois.edu or at the 1-800 number on the screen here. We do prefer emails. It gives us a little bit more time to collaborate within the office and get you the best answer possible. But if you do have a quick question and want a rapid response, that 1-800 number is available. As far as our online resources, all of our previous workshops and webinars are archived on our website. We have self-paced online courses, direct links to our technical support contact information there. We also have links to the energy codes so that you have a quick link to access that information rather than trying to hunt for it yourself. So it's a one-stop shop for all your energy code information needs. We also provide a frequently asked questions and answers section on the page there. As far as our upcoming webinars and workshops, we are at the end of our current program year, so we're in the planning stages for our next program year. If you have suggestions or topics you'd like us to cover, feel free to reach out to us at energycode@illinois.edu with some ideas. We'll be happy to entertain those and see if we can include them in our upcoming programs. So keep an eye on our website. The schedule of events will be listed there soon. But again, if you want to see any of our previous presentations, workshops, or webinars, please find those at smartenergy.illinois.edu/energy-code. Todd, would you like to give a quick introduction to yourself?
Sure. So I'm Todd Abercrombie, president of Midwest Building Performance. I do energy audits and energy efficiency performance contracting throughout Central Illinois. Goals, of course, are energy efficiency, solving comfort, solving moisture, and value to homeowners and business owners. Short and sweet.
Right.
Oh, right. So I worked as a consultant and a contractor for homeowners, contractors, residential and light commercial construction. Number of services there, energy audits, code testing, infrared, moisture. I'm also a trainer. If you've heard of BPI, I'm a BPI test center and a BPI test proctor. I'm also an adjunct instructor at Illinois Central College, and of course have several certifications related to the field as well. Thank you.
All right. So let's go ahead and dig into energy code and verification sections, those parts of the code that list verification and testing requirements. Just a quick update. It's looking like towards sometime in October will be the adoption of the 2021 IECC. That was intended to be sometime during the summer. But with the current updates that we've got, we believe that will happen in October now. So there will be some updates that we'll cover throughout the presentation, touching on how the 2021 is going to be different so that you can start planning for those changes. The big thing is air leakage testing. Everyone knows about the requirements for residential air leakage testing. It is currently in the 2018 an option for commercial buildings using the ASTM E779 pressure testing standard. In 2021, this will become mandatory. There are some exceptions listed in the code, but they do not apply to Illinois' climate zone 4 and 5. So all commercial buildings will also have to have pressure testing completed. That's a really big change in the upcoming code cycle. But all three standards that apply to residential will also apply to commercial instead of being limited to that E779 standard. A couple different ways you can do that testing. Shown on screen here, you can either have for multiple fans linked up in the building, you get the airflow going through all those fans to figure out the total leakage. You may do this total leakage testing for smaller commercial buildings. When you get into larger commercial buildings, you can do sampling. Samples are required for the ground floor where you have entryways into the building. And if you have sub-levels that have exterior entryways, those would have to be tested as well. All floor areas underneath the roof, so top floors of buildings, generally will have to be tested. And then a 20% representative sample of the rest of the envelope. And as we touch on how we do testing later, you'll kind of see how we can break the building up and do testing in different areas. So which testing standards should be used? In general, most of these are about the same. There's very little difference between them. The big difference is the ResNet IECC standard 380 also includes residential pressure testings for duct and HVAC systems, as it encompasses more of the entire building testing standards, where ASTM E779 and ASTM E1827 are both blower door test standards. They all apply to single zone buildings, limited wind gusts, so they're not adjusting for pressure changes. So it's going to take a little planning, checking the weather and stuff to do this kind of testing for your buildings. But in general, any of the standards will be applicable, especially once the 2021 IECC goes into effect and these apply to commercial as well. So looking at commercial systems, some of the HVAC components must also be tested. So in commercial buildings, duct insulation and sealing requirements must be verified. They must, an inspector is going to look at the ductwork and make sure that the seams have duct mastic or some kind of UL 181 rated tape on them. For high pressure duct systems, it's the one part of the commercial building codes that requires duct pressure testing. If that static pressure designed for the duct is 3 inches or greater, then they must be tested per the SMACnet HVAC air duct leakage test manual. This does allow sample testing of the ductwork, so you're not testing the entire duct system. So you would isolate a portion of the ductwork, do the leakage test in that section. But there is some testing that is required in commercial duct systems. If you're 1 inch or 2 inch static pressure, then testing isn't required, but you do still have to do the sealing requirements, and that does need to be verified by the building official. And they'll probably do spot checks to look at that. On the residential side, duct insulation installation, just like commercial, needs to be checked. verify that you have the proper R value for the duct's location, and that it's properly applied to all sections of the ductwork. And then duct sealing, again, spot check, visual check for sealing, but you're going to have test results for the residential side for ductwork that's outside the conditioned envelope. For ductwork that's completely inside the conditioned envelope, the 2018 IECC does not require pressure testing for that. So if the HVAC unit and all the ductwork is inside the conditioned envelope of the building, testing is not required. But you do still have to verify that ductwork has been sealed appropriately. The 2021 will update this. Testing will be required, but the leakage rate is a little bit more lenient for ductwork that's entirely within the conditioned envelope. The reason being, we still want to make sure that air is getting to where it's needed and it's not leaking out somewhere else, so that your rooms are going to be evenly conditioned throughout the residential building. But that is a change that is upcoming with the 2021 IECC. For commercial buildings only, where you've got more complex control systems of the HVAC section, those sections or those controls need to be commissioned. The commissioning report needs to be submitted to the code officials so they can verify that this testing and verification is going to take place. And then a final report, once that testing and verification has been done by a commissioning agent, will verify to the code official that that work has been done. So they do need to see those follow-up reports. There are two reports. You're going to have one is your initial commissioning report. It's going to detail any faults or errors in the control logic that need to be repaired and how they're going to be repaired. And then there's a final commissioning report that notes that those repairs have been made right before building occupancy. There's also functional performance testing requirements. This details the types of commissioning tests that need to be done and the checks to be made on those systems. So those are enunciated in the energy code in the C408 section. Similarly for lighting, as you have more advanced controls in commercial buildings, those advanced controls need to be tested to ensure that they're working properly. You're not going to have lights turning on when no one's in the space. We've seen in the past, sometimes someone walks past an office, an occupancy sensor picks up that movement in the hallway and turns on the office light even though there's no one in there. So testing and verification is going to ensure that those kind of installation errors don't happen. Timers are properly set to turn the lights on for the occupied period of the building, turn them off when the building is unoccupied. We're going to test that photo cells and daylight controls are working properly for indoor and outdoor lighting, that dimming features work properly. All that kind of testing is also detailed in the C408 section of the energy code. So before we move on, we do have a quick poll question here. Our first question is, which pressure testing standard is allowed for commercial blower door testing per the 2018 IECC? There was one of them that was allowed for commercial buildings. And then which is true of duct testing? Duct leakage testing is optional for both residential and commercial. Commercial only requires high pressure ducts to be tested, or commercial and residential testing of the entire duct system is required. I don't see any questions come into the Q&A yet. Again, if you do have those, please enter those in there. Quick answers we'll try to get to at these poll questions. Longer answers we'll try to get to at the end of the presentation. Okay. Got a few more answers trickled in. We'll give it a couple seconds here. All right, let's go ahead and share those results. So it looks like most people picked up ASTM E7079 is the commercial testing standard for the 2018 IECC. If you do that optional pressure testing for commercial buildings, that is the standard that is currently required and the only one accepted. In the 2021, all three of those will be available for commercial buildings as well. And for our second answer, it looks like most people got this one correct as well. Commercial only requires high pressure ducts, that 3 inches of static pressure or greater design pressure must be tested. Duct leakage is only optional for residential if it's all inside the conditioned envelope. If you have any ductwork in the attic or a crawl space, then that ductwork needs to be pressure tested. And commercial and residential testing of the entire ductwork isn't required all the time either. Commercial, it's only required on sections of the ductwork that have that high pressure label on them. And again, for residential, it's only required if ductwork is outside the conditioned envelope, so it's not always required. So the correct answer there is that middle one. Those high pressure ducts need to be tested. So let's get into the actual requirements. What is the testing details? So on the commercial side, if you do that optional pressure testing for commercial buildings, the pressure test has to be at 75 pascals. That simulates about a 25-mile-per-hour wind on all sides of the building. Leakage is based on the exposed envelope area. So it's at 0.4 CFM per square foot of envelope area target. And you can do samples of the building and area weight the averages of those in order to get an overall building leakage. So you don't have to test the entire building at once. Depending on the size of the building, that may be easier. Smaller commercial, go ahead and do a full blower door test for the whole building. For larger buildings, you're going to want to take advantage of that sampling protocol. On the residential side, the pressure is slightly lower, and this applies to commercial multifamily buildings as well. That pressure test is going to be at 50 pascals. For townhomes and single-family homes, leakage is based on volume. So it's a 3 air change per hour in the 2018 IECC. Per Illinois amendments, it's 4 air changes per hour currently. In the 2021 IECC, they're going to align with the code and make that 3 air changes per hour. And in general, out in industry, we see that that's pretty standard for most people to be able to achieve that. For multifamily buildings, currently with the 2018 IECC, there's an Illinois amendment that details multifamily pressure testing samples. And so this is not based on volume of the building. It is based on the enclosure area. So it's 0.25 CFM per square foot of all sides of that unit, including interior walls. It's what's known as an unguarded blower door test. So your neighboring units don't have to be pressurized or depressurized, depending how you're running your test. That test pressure is at 50 pascals. The leakage limit, again, is a 1/4 of a CFM per square foot of exposure area. So it's all sides of that enclosure. In the 2021 IECC, it's going to get a little bit more lenient. We haven't heard yet whether an Illinois amendment is going to maintain that 1/4 CFM per square foot. But in the 2021 IECC, it's about 0.3 CFM per square foot instead. And the sampling protocol does allow for, if you've got more than 7 units in the building, you can do a 20% sample or 7 units, whichever is greater. So once you get above 8 units, you're going to have a 7-unit sample as your base number, and then 20% of the units in the building. So as long as you're testing at least 7 units, that's the bare minimum. So who's going to do those blower door tests? For commercial buildings, if you're doing pressure testing, it's usually going to be a third-party contractor that specializes in pressure testing large buildings. Commercial buildings have a lot more openings in them than residential. You've got ventilation dampers, openings for HVAC equipment. Those things need to be sealed up to test the envelope of the building before you run the pressure test. So finding, locating all those, knowing where those are commonly at to do that testing takes a little bit more training than just a simple residential test. Takes a little bit more time as well. As far as who can do that testing, as long as their credentials are acceptable to the code official or the authority having jurisdiction, then that testing agent is approved. Similarly for residential, it can be third party or the builder. The authority having jurisdiction just has to approve who is doing that testing. Most of the time, it's a third party, a HERS rater or air pressure testing contractor. But there are some builders that do their own blower door testing. A lot of times what we've seen is the code official request to be on site for the test so that they can verify it's done appropriately. Installation inspection is also something that must be completed for commercial and residential. Usually it's verified by both by a visual inspection for both commercial and residential buildings. So just making sure the insulation is properly installed. You don't have any gaps or areas where that insulation is missing. Full contact with the insulating surface. And if you're doing spray foam installations, you're checking for proper depth, adhesion, things like that, that there aren't any issues with that spray application. Usually, again, for residential, as part of a rating process, a HERS rater will be able to do that inspection and submit that as part of a report to the code official. Code officials themselves may also do kind of a spot check of insulation and just verify if these things are properly installed. Similarly, on the commercial side, there's the plan review. The inspector knows what types of insulation are going in place, and they go out on site for some of their inspections. They may either do a dedicated insulation inspection or maybe part of other inspections that they're doing. So they're going to just check and make sure that there aren't any obvious issues with the insulation work. So I kind of just touched on this as far as who's doing that verification. Some best practice ideas. During the installation work, it's best if the construction manager, architect, designer, somebody is dedicated to do just quickly go out on site and just check ongoing work to make sure that best practices for installation are being followed and there aren't any issues. A big thing that we commonly find is if we wait until all the insulation is installed, sometimes issues get covered up. Especially issues with air leakage through the envelope into the insulation. And so if you're spot checking this work throughout the process, sometimes you can catch those issues ahead of time before they get covered up and avoid destructive repairs later if testing finds a problem. Final compliance verification is going to be through a code official's site inspection though. They're going to do a quick spot check of the insulation and make sure it's all in the proper place. On the residential side, again, as I noted, a HERS rater can review that insulation installation. They submit the report to the code official, being a third party. Usually, most code building offices will accept that insulation report. For air sealing, a quick visual inspection for duct sealing. Visual inspection of sealed joints on the commercial side. If you've got high pressure systems, they're going to confirm that leakage class. Testing has been done. So you're going to follow that test manual to meet a leakage class of 4.0 or less. And the way leakage class works is you test the duct work. I believe it's leakage per 100 square feet of duct surface area is how that's measured. On the visual side, again, there's a visual inspection for sealing. If you're not doing testing because it's all inside conditioned space, you're still going to have that visual inspection to make sure duct mastic or tape is applied to duct seams as appropriate. If you're doing the pressure test on the whole duct system, the leakage is based on floor area, so less than 4 CFM per 100 square foot with the HVAC system installed. So the supply and return sides all connected through the HVAC system. If you test the supply and return side separately, it's 3 CFM per 100 square foot of floor area. You test the supply and return separately and add those values together and then divide by the floor area of the building to get that total leakage rate. On the commercial side, usually it's going to be an HVAC contractor that does that pressure testing. Through the installation process, if testing isn't required, a construction manager or someone should be inspecting the sealing process periodically. And then the code official is going to verify during their site visit with a couple of spot checks. On the residential side, it can be done by a HERS rater if you're doing the rating process or you're involving a HERS rater just to do your blower door testing and things like that. But the entity just has to be acceptable to the authority having jurisdiction. So it can be the builder and the code officials on site during the testing to make sure it's done properly. It could be a separate contractor or it could be a rater, as long as it's acceptable to the code official. For commercial control systems for HVAC and lighting, C408 section of the Energy Code lays out the process for commissioning. So the designer's going to document the systems and the control sequences in plan drawings or in the construction documents. We're seeing a lot more now that there is a specified set of plan drawings that goes over the controls. It lists the sequences of operation for the different systems, has diagrams of what sensors are placed in the system. Once those documents are submitted and reviewed, make sure that all the proper controls are planned for. Then a designer commissioning agent is going to develop a commissioning plan. So they're going to be working together to figure out how do we test these systems, what's the appropriate metrics for identifying whether they pass or fail. That's probably the hardest part, is coordinating between different units, the designer and the commissioning agent, to make sure that all the different control points are documented and have an appropriate test protocol set up for them. So it takes a lot of coordination up front. The commissioning agent is going to do the testing on the systems then in coordination with the contractors. Systems have to be installed and functional for the testing to take place. So you don't want your commissioning agent showing up and then things not being ready for them. So again, a little more coordination needs to take place there. They're going to document in an initial report issues that need to be corrected, submit that to the code official, the building owner, and the designer for the building, so that they know what needs to be repaired. Once those are completed, then a final report is completed by the commissioning agent and submitted to the code official. It's also included in the building owner's building manuals. The big thing with this commissioning is that that initial plan is a collaborative effort between the designer, the construction manager, and the commissioning agent. You got to make sure the timing is set up, the testing protocols are in place, and that you've covered all the different things that need to be tested. The functional testing itself is going to be completed by a commissioning agent or the contractors doing the installation, so the HVAC contractor or the lighting contractor. And they may have some oversight by somebody such as a commissioning agent to make sure that tests are done appropriately. For HVAC systems, system balancing on air side and hydronic side is usually completed by a test and balance contractor, and a report is generated for that. All those different reports are compiled by a commissioning agent. Again, they're going to have a checklist of items that need to be addressed. As far as a code official, how involved they're going to be, they're going to look at the initial commissioning plan. They're going to have in the construction documents or the plan drawings, those sequences of operation and the drawings for control systems. So they'll review those. But largely, they're going to be relying on that commissioning report to make sure that the testing and verification has been done appropriately by the appropriate contractors. So we have another poll question here. For duct leakage testing, who is the party responsible for testing? The ResNet or BPI certified contractor, the builder or construction manager, any entity acceptable to the authority having jurisdiction, or the HVAC contractor? And for our second question, what's the biggest issue in conducting commercial commissioning? Coordinating testing among the multiple contractors, coordinating testing with the code official site visit, or completing the final commissioning report? We've had one question come in. Are warehouses required to be tested? How are large 100 to 1 million square foot warehouse testing being a large open space. So currently, the testing that needs to be done for those is mainly the HVAC systems controls and the lighting system controls. It's mainly that commissioning that needs to be done. When we get to the 2021 IECC, pressure testing will be required for those buildings. There isn't an exception for warehouses. As far as how that's going to be done, being a large open space, it's either going to be a lot of blower doors, or there are like truck mounted fans that are larger units, so they can do that cover that larger area. I believe it may also be possible to partition off sections of the envelope and not test it all at once, but test it in sections. You would have to hang something like visqueen sheeting or something over a section of the envelope and test that section if you don't have access to a larger fan system. But yeah, certainly for larger buildings, we'll have to get creative with testing. Todd, have you put any thought into larger commercial buildings?
That's exactly what you said. You need a bunch of fans or a truck mounted fan, or I'm just imagining warehouses with 20-foot ceilings that are wide open. It's going to be really difficult to partition it off. Mm-hmm. It's going to be case by case.
Okay, we'll share our poll results here. Looks like our first question, most people got it right. For duct leakage testing, the entity just has to be acceptable to the authority having jurisdiction. Could be a HERS rater, could be the HVAC contractor, could be the builder if they know how to do that testing and the code official supervises it. And for our second question, yes, the biggest issue is coordinating commissioning amongst multiple contractors. You got HVAC, you've got lighting, you've got the commissioning agent themselves. So there's a lot of coordination that takes place there, and that is fairly difficult. So that's most of the upfront work there. I believe now I'll be turning over to Todd. He will cover how to actually do the testing and verification, and then I think we'll have a poll after that section.
All right, sounds good. Thanks again for having me today. Hopefully everybody's staying cool. It's a good time of the day to stay inside, not in the attics or even just walking outside. All right, so let me make sure I got my slides moving right. Okay. So for controls commissioning, I think Sean mentioned earlier, there's pre-developed commissioning checklists. This checklist you can use. There's a good link online there to get some of those for commercial buildings. For what are you checking on HVAC for commercial buildings? Well, balancing air and water flows, of course. Control operation matches design sequence of operation, and then you must test in both heating and cooling seasons. As far as lighting, what are we going to check? Well, the controls in each room's geometry, where the room has same geometry, fixture placement, and orientation. The room has mirror geometry or shifted fixture placement. You know, there's different scenarios there, but your test parameters, of course, are sensitivity, false triggers, overrides, schedules, room coverages. For duct leakage testing, I think we've kind of covered it a little bit already, but we've got commercial and residential testing to do. On the right there is the Energy Conservatory's duct blaster, which is good equipment to do it. For duct testing procedures, again, on commercial, you're going to refer to the SMACNA test manual, which will show you what to test for in the appropriate leakage class. The leaks are measured in CFM per 100 square foot of the duct surface area, which is a little bit different than the area like in residential, where you're calculating the area, square footage of the area the system's serving, or floor area. Commercial duct test pressure, usually 25 pascals. And then you often need to seal the section of ductwork to conduct your test on. On the residential side, the 2018 IECC defines test pressure again at 25 pascals. And your passing results again are based on floor area. So as you mentioned earlier, duct leakage is 4 CFM per square foot of total floor area the system serves. If you don't have the air handler installed, then it's 3 CFM per 100 square foot of the area that the system serves. And of course, without the air handlers installed, you're going to need to test the supply side separately from the return side and add the two leakage rates together to get a combined number there. Duct testing systems, the term, I find contractors have a lot of different terms for the test. Duct pressure test is probably the most common one, but duct blaster test, duct leakage test are also used. On the lower left side on the screen there is the RetroTech duct tester, which is a good system for using on residential. And then in comparison, the Energy Conservatory version there is on the right. They're basically like small versions of blower doors. Both companies have blower door systems. They also have duct testing systems. And basically walk around, seal everything up in terms of all supplies and returns, and then you're going to pressurize or depressurize the system. So if you're depressurizing, you're basically sucking air out of the duct system. If you're pressurizing, you're blowing air into the duct system. Having done both versions in the same houses before, there really isn't really any significant difference in the leakage rates. They're basically the same. I tend to favor the depressurization mode myself because if you're putting like a duct mask, a tape over your supplies and returns, it kind of pulls that tape a little tighter. But again, if you flip the fan around and do this pressure test, you're probably going to get the same leakage rate anyways. Basic setup when testing duct system, again, seal off all of the registers and grills. The HVAC system, if present, should be turned off. Any air filters are removed for the test. Seal off any combustion air inlets and ventilation air inlets, etc., before turning on the test. The lower left picture is a test done at the rough end stage. Obviously, you've got the boot coming through the subfloor there, and there's just tape over the surface area there. On the upper right is a example of testing when drywall has been installed already. Highly recommend, if you need to do this test, do it at rough end stage before drywall is installed. If there's any issues, any additional duct sealing that needs to happen, it is much more difficult to do so after drywall. So often during rough end stage, the duct tester will show up and do the test, sometimes before electrical is even powered to the facility or the building. And generally we bring our own power to power our fans. But by far that's the best time to get it done, because again, you can figure things out and get things passed quicker. So what happens if you don't pass that test? The duct tester should be there to provide some additional diagnostics or some direction at least. Some duct testers are simply third-party testers, and they'll kind of help you find things to seal. Some of them will also do some sealing. It just depends on who you're working with. But of course, verifying all seals are holding up from the test setup. So for example, we just taped all of the supplies and the returns in the house. Let's walk around and make sure we didn't miss one, because that might be the first reason. So let's check the test setup first. If that's not the problem, then if possible, you may be able to isolate your supplies from your returns. So if the test is done with the air handler installed, you might be able to block off, let's say in a return filter slot, and just test the supply side and figure out what that leakage rate is, and turn around and do this return side. That will tell you if the leaks are more predominantly on one side or another. So you can kind of narrow down the time spent doing additional diagnostics. You can also check the pressure at each supply and each return by taking a little probe, sticking it into the temporary tape, and a manometer will tell you if you've got sort of a big problem in that section of duct. Because that's always the hope if you don't fail a test, is to find the big hole and seal it. But chances are it's not necessarily a single hole, it's a lot of small stuff that adds up. And then the other option you could do is use a theatrical fogger or smoke machine to basically smoke the system. So you basically blow smoke into it. So you have to pressurize the system, blow smoke into it, and then walk around and look for smoke coming out of the different seams in the ductwork. It is a useful test, but having done it in reality, it can be a bit of a mess, because after you let it run for so long, that fog literally will fill up the room, the basement, the house, the building, wherever you're in, so much so you can barely see 10 feet in front of you. So we try to save that as sort of the last resort if we can't figure out in other ways. So in my opinion and experience, start with the simple and the quick first, and then work towards that if you need to. Different materials that can be used. Duct mastic, you see there in the middle picture. Basically, it's painted either with a brush or with a hand in the glove over all the different seams. Foil tape can also be used. You see some there on the right picture on that wall stack. And then on the left, this is a picture from an existing building, but obviously a big catastrophic hole like that would be a problem for a duct test. So get that sealed up with some sheet metal and screws and mastic or tape or whatever. But it's sort of the nth degree or the gold standard for duct sealing is a product called AeroSeal. And that's a company that comes in and actually does the duct sealing by injecting an aerosol mixture into the airstream, and it seals up gaps, I believe, up to like 5/16 of an inch. And as long as there's not catastrophic holes, by doing AeroSeal, you really shouldn't need tape or mastic by doing that. But sometimes you need a little bit of a combination of things. But of course, using AeroSeal is going to be an expense. Some contractors also look at that as saying, okay, well, there's an extra expense of bringing AeroSeal in, but I'm also saving all the labor of all the time spent sealing the ductwork. So there can be a cost benefit analysis that you have to think about there. Moving into building pressure testing. Of course, we've got commercial and residential buildings that are requiring testing today. On the left there was the RetroCheck version, and on the right, the Energy Conservatory version of the blower doors. But so why do we do blower door testing in the first place? Well, to start off with, it tells us how leaky or how tight the building's going to be. Generally speaking, the tighter we construct the building, the more efficient that building's going to be, the more comfortable and more even the temperatures throughout the building are going to be, and the less likely you can have potential moisture problems in wall cavities and attic spaces and interstitial spaces. But the blower door test, of course, gives us that big leakage rate for the building, but it's also a diagnostic tool. While the test is running on the residential side at 50 pascals, that's equivalent to a 20-mile-an-hour wind on all sides of the building at once. So you can quite literally walk the building and literally feel air coming in at different leakage points. It may be around doors or windows, could be through a recessed light fixture, it could be around an attic access point. You quite literally can feel them with your hand. You can carry a little smoker with you and smoke around certain areas and watch the air movements. It's a great learning opportunity, not just for the person doing the test, but for the occupant or building owner or whoever's using the building to kind of understand where their air leaks are. It can diagnose building pressure problems as well. Some areas have more pressure than others. You can evaluate moisture problems like condensation and mold by understanding the tightness of the building and its connection to the attics and crawl spaces and other areas. We also do blower door testing, at least on the retrofit side, is a test out procedure. So you do a before and an after, so we can quantify the reduction of air leakage. So basically how well the air sealing crew did their job. And of course, if you do a blower door test on the new construction, doesn't pass, you write up a scope for remedies, come back, do the second test. Well, you obviously can quantify your reduction there. But most importantly, does it meet the threshold to pass code? And some crews, some working crews, some installation crews can actually use the blower door test during the job while they're actually air sealing. In the right situations, they can hook up the board or do the air sealing work and literally check their work before, blown insulation is installed or wall insulation is installed or whatever. So you can help test your work while on site. And again, which blower door standard are we using? Code says in the ECC 2018, ASTM E779, ResNet 380, ASTM 1827. Those who do blower door testing have probably been trained by ResNet or BPI. They reference different standards. Not all of those standards are referenced in the code, so you kind of have to just kind of be careful of what context you're doing the blower door for. But for example, the BPI standard, they do reference ASTM E779. They reference a Canadian standard, and they reference Section 802 of the ResNet standard, which is a little older version than the code ResNet's referenced by code. So just be aware of what standard you're using there. And in terms of preparing for a blower door test, well, I think probably the number one takeaway I would want everybody to have on this call would be, if you're required to do a blower door test, you need a plan for air sealing before really the building has even started construction. The questions are going to be, how are the walls going to be air sealed? How are the ceilings going to be air sealed? So there's a separation between attic spaces above those ceilings and not. Because if you do a blower door test and fail, and you're at drywall stage and all the insulation's installed and there's problems, nobody wants to go through the attic and swim through all that fibrous insulation to try to seal something. So having that plan in place at the beginning is critical. It's not super complicated. You're looking for penetration through ceilings, of course, exterior walls, through foundation walls. On the left there's an image from Energy Star. It's called the Thermal Bypass Inspection Checklist. It's a great little reference guide to just sort of go down the list and say, what should we air seal? Who's responsible for it? Who's going to verify it? During those insulation inspections, like by a HERS rater, they will actually use this checklist to go through to make sure things are sealed before we start buttoning up the building. As far as the test goes, the basic setup of a blower door, the envelope needs to be basically closed up. So of course, all your windows are closed, exterior doors are closed. Interior doors, unless you're doing some kind of sampling testing, are all going to be open. All your exhaust fans are turned off, all your air handlers are turned off. You set your gas appliances to pilot so they don't fire up during the test. Chimney dampers are closed, etc. So you set up the building in a very quiet condition, so nothing's running and it's as closed up as possible. There's a couple different test methods that these blower door standards will reference. One's called a single point test and the other called a multi-point test. With a single point test, it's simply you bring the building to a test pressure of 50 pascals with respect to the outdoors, and then you look on the other side of the manometer to get your reading, your test result. With a multi-point test, it is going to take a series of 5 or more test pressures and take readings at each of those test pressures. The one I use most often is it actually takes readings at 8 different test pressure points, as low as 10 pascals and as high as like 60 pascals. But then it will calculate what the actual CFM 50 or the ACH 50 that we need for code compliance. The multi-point test isn't necessarily a lengthy test. It's a little bit longer than a single point test, but once you're hooked up and you start the test, I would say 3, 4, 5 minutes at the most to run through the multi-point steps. So it doesn't take very long. But usually the manometer or the reports generated by Energy Conservatory and Retrotech will provide sort of a graph of the test pressures and all the readings for that. And then here's something I call intermediate blower door testing. If you're in a situation where you need to get a blower door test, it doesn't have to be done after drywall. Generally speaking, that's usually when we do it because that's the final of the job. But I've had some clients building some new homes. In this case, this was one of them you see in the picture where we came in and did the blower door test before any insulation was installed. And in this case, they had a SIP ceiling, so we didn't have to even put drywall on the ceiling. Garage overhead door was closed, but the garage in this case, when that picture was taken, was actually wide open to the house. But we still went ahead, did the blower door test, walked around, found the different air leaks, did additional air sealing. And before we left the house in that condition, we were already below code requirements, before insulation, before drywall. Again, if you really want to get this done and get it done right from the get-go, I would, it's possible, not always possible, all buildings are different. An intermediate might be something to consider. You need a reasonable part of the envelope done. And then the test results, the reference by code is on a scale of ACH 50 on the residential side. So the IECC says 3 ACH 50 or less for climate zones 3 through 8. Illinois previously amended the 18 to 4 ACH 50. But basically what that means is the number of times the air will change in the house at the test pressure that the blower door is running at, the CFM 50. The rough way to consider what a scale of ACH 50 looks like is let's call it a 0 to 20 scale, where 20 ACH 50 on the right was considered very leaky construction, and 0 ACH 50 on the left, of course, would be perfectly airtight construction. For efficient homes, we obviously want to be on the left side of the scale, not on the right. Less than 3 ACH 50, of course, considered very efficient. That would be code compliant today. Less than 4 is code compliant in Illinois based on the Illinois amendments to the code. And less than 7 is sort of efficient. This is more of a existing building kind of metric. And of course, when you're getting in the 10 to 20 range, you've got tons of problems. And of course, theoretically, you could be over 20, but you're really off the charts. But again, roughly speaking, we want to be on the left side of the scale for code compliance and for efficiency. So what if you turn on the blower door test and you find that the test doesn't pass yet? Well, the next step the tester should be doing is helping figure out where the biggest leaks are. What's the biggest bang for the buck that's going to get you to pass code? So again, you walk through the building, look, listen, and feel. If there are, say, curtains installed or something that's blowing in the wind, well, you know there's air movement. Sometimes you can hear a little whistling through different gaps and cracks. The feel of the air coming through the envelope, through the walls and ceilings will tell you a lot. But there also can be zone pressure diagnostics done. Basically, with the blower door running, we take another manometer, and anywhere a door can be closed, you can throw a hose under the door. We're going to talk about this here in a minute. We can do a little pressure pan testing, and even a thermal imaging camera in the right conditions can also help and do some quick diagnostics to figure out what's going on. So the zone pressure diagnostics, you have the blower door test, the blower door running at the test pressure, and then you walk up to a room, throw a hose under the door, close the door, and take a reading with a manometer. And basically you're trying to get determine if that room is leakier or tighter than another room. And if it's, of course, leaky, then we know we need to figure out what's going on in the room that needs addressed. Super fast test to run. Generally speaking, when you look at the manometer, the one they're pictured on the floor, your range should be 0 to 50. You want close to 0, which means that room is within the envelope of the house. If it's 5, 10, 15, 20, or even higher, that room is very leaky and has a lot that needs to address to tighten it up. Here's this kind of a scale of what I'm just talking about. If it's under 25 pascals, that room is considered more inside, more connected to the interior of the house. But again, we want it as close to 0 as possible. We don't want it anywhere near the other side of the scale. Anything above 25 pascals is considered more outside. And I'm talking about testing rooms that are considered part of the envelope of the building, things that are conditioned with our heating and cooling systems. In contrast, an attached garage typically is not heated or cooled through our HVAC system. So we want that room to have a tight connection from the house. So with that same scale, I want the garage to be 48, 49, 50. I want it to be completely disconnected in a pressure test anyways from the house. And again, you just take a hose, throw it under the door, close the door, test the garage to house connection, and can quickly figure out if there's any issues between those two surface areas. This was just an example. If the garage to house connection had a rating of 5, this would be a bad example, or shows lots of opportunity for improvement. Unconditioned attics, very similar kind of test. Use the zone pressure diagnostics. You can find a way to stick a little hose around the attic access through a little hole to test the attic space in relationship to the house. You can quickly determine if the problems are between the attic and the house, and whether you need to spend more time doing that. So the zone pressure diagnostics helps quickly evaluate areas of the building that to find some of the bigger issues that need addressed. And of course, can help document before and after test results. Because we come back again, do a second test, we can check that zone again. And so another test you can do that's pretty quick, again, with the blower door running, is called a pressure pan test. And this is usually used when you have ductwork in an attic, ductwork that's running through an unconditioned space. You basically have the box there in the picture. You place it over the diffuser in the ceiling. I have another manometer, and basically take a pressure reading again. With the blower door running, HVAC system's off, you can figure out if you've got any air leakage issues related to ductwork in the attic as well. So that's a pretty quick test. And then the thermal imaging camera, obviously very helpful. We use these to troubleshoot buildings, whether new construction or existing buildings, to evaluate the building envelopes, find insulation and air sealing issues, and even certain moisture issues. One big caveat though, whoever's using the infrared camera has to understand temperatures. If you're looking at a wall, let's say the indoor space is set at 70 degrees and the outdoor space is very nice, it's 70 degrees outside, 70 degrees inside, you're not going to see much with an infrared camera. You really shouldn't see anything. So you won't be able to detect problems if you don't have a temperature differential. Most cameras need 18-degree temperature difference between indoors and outdoors to get a decent picture. You can spend a little more money and get a little better resolution, and maybe 10 degrees is your limit. So the person using that camera has to understand that there's an appropriate time of day or even season to use the camera. Now, a 70-degree day inside and outside might not be good for the walls, but if it's sunny and the sun is hitting that attic temperature is definitely not 70 degrees. It might be more like 100, 110 degrees. So you could use the camera to look at your ceiling in that scenario, but you can probably see lots of opportunity, but not necessarily through a wall. I can't stress enough that you got to understand your temperature differentials as well. You can't just pick it up and see everything you want to see. And it takes a little bit of experience and training. So again, taking pictures, you have to know your temperatures indoors and outdoors. IR doesn't work when outdoor temperature and indoor temperature are the same. Need the temperature differential. and whatnot. And also another thing to keep in mind is it shows surface temperatures only. If there is, sometimes they try to use these to solve moisture problems or detect moisture problems, and it can be a useful tool, but it's definitely not the only tool. There can be moisture in the wall that's not reflected on the surface temperature of a wall. So you can't look at the wall and just say, oh, there's no problem. This is a infrared camera shot taken during the winter. This is a master bedroom ceiling. And I don't think you have to be much of an expert to see that ceiling's very cold for, 12 foot of that, roughly speaking. So the big question is, why is that ceiling so cold? If there was insulation there at all, it should be, somewhat orange, but it's definitely bare. And we're about to see why here in a second. This is the same house, the picture from the outside. And as I was doing my initial walk around the building, this was taken in the winter. I knew that room was going to be a problem by just looking at the roof. On the left picture, you can see it's cold enough to have some frost on the roof. You see the frost here on the upper roof. But on this lower roof, which happens to be above the ceiling of that room, there's almost no frost at all, which is telling me that this is probably an attic that's not insulated at all, and that heat from the master bedroom was just going right through the ceiling, right into the attic, and warming that roof deck to a point that it didn't have frost on it. You only have frost at the edges where it was overhanging the outdoors. So just looking at those two adjacent roof lines quickly tells me this is a problem area. And this is the side view of that ceiling. You can kind of see where the ceiling is going to come across, and we're going to have a knee wall here between the second floor and this attic space. I'm not sure exactly what had happened. This was a fairly new house, only a few years old, and there was no attic access to that space at all. So obviously I would just call that a forgotten attic. Hopefully an insulation inspection would have caught that during new construction. When the camera is being used at the same time the blower door is running, you actually can see air leakage, again, with your right temperatures. So I know the image on the right is a little hard to see. That's basically, looks like a smoke detector in a ceiling. But on the left, you see almost that starburst effect. You're seeing the air leakage as rendered with the blower door running at a leakage point. Obviously, the attic above that must be very hot, must be a summer shot, very leaky. If I were to take that picture in the winter, I would basically have the reverse problem. I would see all this blue coming in instead of all that brightness. But again, fairly quick way, once you have the blower door on, to find penetrations that need addressed. Top plate leakage is a very common problem for houses, very common leakage rate. One stat that I heard, I think from the Department of Energy, was of the air leaks between the house and the attic, as much as 20% of them is simply from top plate leakage. This image was taken in a hallway, so you've got conditioned rooms on both sides of the hallway. It was taken in the summer, and blower doors running, and so you see all that hot air coming down through the top plate, down through the interior walls, and then through light switches down into the basement, all kinds of places. So getting top plates sealed during the new construction phase is much easier than digging through insulation later, trying to seal top plates. This is a winter shot. This is kind of what you see in the winter, where you see your air leakage. You've got an attic access panel in the ceiling. There was no weather stripping underneath this panel. Pretty easy fix there. Looks like we need some caulking there on the side as well, on the side of the trim. So we know that's a problem. This is a top plate leakage over a return in a wall cavity. Now, this was an existing building shot. If we're doing new construction today, we probably all know returns are fully ducted. So top plate leakage shouldn't be impacting the returns. But in previous homes, older homes, that wall cavity was connected to the ceiling, essentially. So any time that HVAC system would turn on and air is coming into this return and going down to the air handler, it doesn't know not to pull air off the top plate, because if the top plate's leaky, it's going to pull air from the attic down into the return as well. So you get about a double whammy problem there when you have a top plate leakage over return. Common other areas, drop soffits. This is one that obviously was not sealed from the attic. We've got a lot of leakage in the recessed light. Another problem that can be addressed. Recessed lights and ceilings are very common problems. Even brand new recessed lights that are considered airtight can still show air leakage between them, not necessarily this dramatic, but they are very, very leaky. So if you're going to use recessed lights in a ceiling connected to an attic, make sure they're sealed before you button up the envelope with insulation. This is an example of what that might look like. This is in an attic. These are recessed light can cover boxes. They're designed to cover recessed lights. They're cardboard boxes that have a fire coating on the inside to prevent ignition. And be careful of what you're using for your air barrier when you're finishing up a building. Tongue and groove paneling, wow, looks very nice, is not an air barrier. That tongue and groove connection is not airtight. As you can see in the infrared picture, blower doors running. You can see all the connection where air is coming through. Ideally, in that situation, if you wanted to use tongue and groove, you would still have drywall taped and mudded behind it, and then tongue and groove on the surface of it. I realize it's an extra step, but from a comfort and energy point of view, it's a potential problem. And tongue and groove can be a moisture problem as well. This was a big A-frame house that had tongue and groove paneling all the way up and down the cathedral ceiling, which again can look very nice from an aesthetic point of view. But this homeowner was having moisture problems. Water was running down his walls in the winter. Basically, air from the building was coming up through these panels, condensing on the roof deck, or frosting on the roof deck and melting, and then water was coming down and eventually coming down the walls. Unfortunately, to fix this particular problem, he has to pull all of that tongue and groove paneling down and then basically redo the entire ceiling, which is not something you want to tell somebody after the fact. Get the air barrier on first, make it airtight, then put your tongue and groove on. All right, I think that's it for me. If anybody has questions for me in the future, there's my phone number and website. I thank you for your time.
All right, we have one more poll question for everyone here. And I see a few questions that come in the Q&A. So why is a multi-point test preferable to a single point blower door test? That's our first question. You get regression of multiple pressures yields a more accurate result, better adjust for pressure swings due to wind during testing, and single point testing requires a 10% penalty when following that ResNet IECC 380 test procedure. And then what is the main difference between new construction and existing home air leakage testing? New construction testing is easier to complete than existing homes. Existing home testing is paired with other diagnostics, and there is no significant distance. Question from Kyle Taylor: has AeroSeal been certified by the IECC? The IECC just requires that pressure testing be completed and passed. The method of doing so is not controlled by the energy code, at least. So AeroSeal is an acceptable means to get that air sealing done. There may be other building codes that impact that, but as far as the energy code is concerned, AeroSeal is an acceptable method. UL 181 rated tape or a duct mastic are all acceptable methods for duct sealing. A copy of the presentation will be available afterwards. Question about how do they correct that forgotten attic?
You have to put an access point in, either from the ceiling of that bedroom or maybe through the gable end, through the siding. And then, I mean, at the end of the day, there should be an access point into that attic, left in that attic space anyways for future upgrades, from wiring changes, inspections later, to figure out if you got a mold problem in the attic. But you either need to go through the ceiling, the knee wall, or the gable end and add an access point. And of course, weather strips, air seal, that whole thing.
Looks like we got most of our polls in. So before we get to that last question, let's share our poll results here. So the first one looks like most people got that one correct. All the above. That multi-point test does help compensate for pressure swings due to wind, and it's a little bit more accurate than a single point test, as you can have multiple influencing factors, and there is that 10% penalty following the ResNet standard test procedure. The main difference between new construction and existing homes. Usually, it's kind of a split here in our answers, but the correct one is the middle answer there. Existing home is usually going to be paired with other diagnostic testing. New construction isn't necessarily any easier. You still got to do all the same sealing and things like that. However, if you don't pass the testing for new construction, you may be doing diagnostic testing to help you focus in on where to work on things.
I would add one other point. If it depends on the tester you're working with, but if you're called out to do, you call somebody out to do a blower door test, and for some reason or duct pressure test, and it doesn't pass, and you're not able to pass on that visit, chances are you're going to pay double for your testing later. You're going to have to come back, bring that person back in again for another trip, another test. So just keep that in mind. You kind of want to be ready when the person is doing the test, because if it doesn't get sealed up that day, then there's going to be a return and another charge, most likely. Depends on who's doing the test for you.
We did have a separate question here, not necessarily a testing verification test, but have there been any revisions to the requirements on recirculation pumps under C404 for domestic water system service water heating? Some people, we've gone to some plumber conferences, and they have noted they've had difficulty finding sensors that meet those flow requirements or pumps that meet those requirements, and there are some Legionella concerns. The standards are about the same. They did some simplification and language changes, but the requirements are unchanged. They just did some clarification to that section. As far as the Legionella-based concerns, the testing that we have found that's been done on these types of systems finds that for commercial buildings that are required to have these circulation systems for compliance, usually they get enough circulation and usage in the buildings that they're circulating enough to prevent any Legionella risk. Specific types of facilities where you've got higher risk of the occupants to Legionella, you may be able to get a health and safety exception for these types of controls. But no, at this time, those requirements haven't been updated. I do know we've tried to do a little bit of digging in our office, and I will see if we can find that information and forward it on to you. And we'll try to reach out to some of our contacts in the plumbing industry with some of that information. But no, at this time, no significant changes to the recirculating hot water system requirements. So we wrapped up a little bit early here. Just a couple of quick notes. Again, if you have questions about the testing procedures or processes, Todd is an excellent resource. Please feel free to reach out to him. If you have general energy code questions, you can feel free to reach out to us at energycode@illinois.edu, and we'll be happy to answer those questions for you as well. Todd covered a lot of detail here about different diagnostic tests. Again, typically we see those applied to existing buildings, but they are very useful if you're doing new construction testing to help figure out if you've got an issue and you're not in compliance, where do you need to focus your efforts? and really kind of nailing down where you might have had an issue come up. For builders that aren't necessarily familiar with air sealing, if they're new to the industry, kind of like a new builder, they just kind of started their company or something like that. It's a good way to learn about where common issues are. And a lot of the issues we've covered in this are common leakage points in both commercial and residential buildings. I see a lot of drop ceiling. Those interior soffits are a very common issue for air leakage points in both building types. Todd, do you have any comments on just kind of the most common places to focus efforts and make sure things aren't missed early?
Just every building is a little different, whether it's commercial or residential. You just have to think about what kind of connections you have through your exterior walls or through your ceilings, or even over floors, like cantilever floors. Just think sort of geometrically around that building and what's going through it, what's connected to it. And that's kind of the starting point. If you can think of it geometrically, then no matter what kind of building you're in, you're going in the right direction.
Okay. Well, we'd like to thank everyone for joining us today. Todd, thank you for your time and joining us today as a guest speaker. Again, if you have any questions for us, energycode@illinois.edu. If you have any questions for Todd, reach out to him at Midwest Building Performance. Thank you all for the time. We hope you have a wonderful afternoon.
Take care.